Remember I told you when you get solving ones, you have to make sure that they're all the same, or that you could GCF something else. So we had ones where we had coses and sines, and we made m's and n's and took an m or an n out. Or we had ones that were sine squared and cos squared. And we had to replace them with sine squared or cos squared so that the cos single or sine single matched. Yes? Then I also talked to you about if you had sine 2x, cos 2x, or tan 2x, they have to be replaced. You can never keep them. We agree? So sometimes on a test, people try and take out a sine x out of sine 2x or a cos x out of cos 2x. That can't happen. It has to be replaced. So the moment I see sine 2x, I know it's got to go. Right? All right. So this one says solve algebraically. This is the catch today, is that this one wants general solutions. So every solution I've asked you so far was not, oh bless you, was not a general solution. It was a specific solution in a restricted domain. Yeah?
Yeah.
This one's general solution, so it's every solution in the world. So we did general coterminal, where we added 360 or 2 pi n NEI. Remember that? We're going to do the same thing for this. So sine 2x is the thing that's got to go. We agree? Why is sine 2x so nice? Sine 2x has one formula. What does cos 2x have? 3 formulas. Sine 2x is a no-brainer. You got to put in what it is, right? So we have 2 sine x cos x equals root 2 cos x. Now, if you had like a cos x in the numerator and a cos x in the denominator, you could cancel those off. We agree? But what you are not allowed to do is divide a cos x out, because you get rid of half of your solutions. So what people do here is they'll often divide cos x from both sides and cross it off. Well, you've gotten rid of the cos x solutions. Yes? So half are gone. So instead of that, what do I always say? We have to get it equal to what? 0. How do we get it equal to 0? By division? Subtracting and adding. So what do we have to do here? Subtract root 2 cos x. So we're going to get 2 sine x cos x minus root 2 cos x equals 0. What can I do next? Yeah. Can GCF the cos x out? If you can't see that, can you make the m's and n's? Does it matter which one you do? As long as you bring the cos and sine back. If you do put m's and n's, right? So we can GCF a cos x out. 2 sine x cos x, take out a cos x. When we GCF, what operation are we doing? Dividing, right? So 2 sine x cos x divided by cos x is 2 sine x. Minus root 2 cos x, what are you left with? Root 2 equals 0. Now some of you, I've seen in the past, just write sines and coses this whole way down without an x or a variable beside it. Make sure you have an x or a variable beside it. There's a few of you on your test who I was graciously nice and gave you some work. So check and make sure you have x's beside your sines and your coses. Okay, at this point we split it, right? We get cos x equals 0. And we get 2 sine x minus root 2 equals 0. Cos x equals 0 is done, correct? Nico, 2 sine x, what do I have to do here?
Oh, you moved that root 2 over?
And divide by 2. What do we do next now? Where are those solutions on? The unit circle. Go look at your unit circle. Your unit circle needs to be up. Yeah, sometimes you can put them together. Like tans are opposite of each other. Okay, cos of 0. Cos is x or y? Is cos x or y? X. So where does cos x equal 0? 90 and 270. Now there are still people who don't look at domains, and if it's in radians, you give degrees every single time. This one you would have lucked out because it says general solution in degrees, correct? So here we have 90 and 270, and people will do this. They'll go 90, 270, and then they box it. What am I missing? That's going to get me no marks here. Yeah. X equals. So that's the answer between 0 and 360. We agree? We will always find between 0 and 360, even if it gives me a wonky restricted domain, even if it gives me anything. We are going to find between 0 and 360. Now, I could write each of these separate. I could say x equals 90 degrees, and then how do I land on that again? Plus 360 minus 360, right? So I could go plus 360 degrees what? N is an element of the integers. We agree? And then I could have to still state the other one, which is 270 degrees plus 360 degrees N, NEI. And if it's a written response, you can 100% just write them both out separately like that. If it's a multiple choice, they're not going to give the answer like that. What do you think they might do? Instead of giving two solutions, they can give one. Do you know how? Yes. 90 plus 180 N would land on the 270, correct? Plus another 180 would land back on the 90, plus another 180 would land on the 270. So you can just write it as one solution as well. X equals 90 degrees plus 180 degrees N. NEI. So multiple choice will come out that way. Numeric or written response, you could come up with both of them, right? It doesn't really matter. All right. The next one, root 2 over 2. That's in your unit circle, correct? Reference angles of 45. Which quadrant is sign positive in? 1 and 2. So it's positive in 1 and 2 at 45. So it's here and here, which is 45 degrees and? Now, can I put these together? If I put them together and I say 45 plus 90 degrees, N, NEI, then I would get another one here and another one here. And are they there? No. So can I put these two together? No. So sometimes you can't. So X equals 45 will be first. 45 degrees plus 360 degrees N, NEI, and then 135 degrees plus 360 degrees N, NEI. What do you think is going to happen in the next one? You try? Catch on this one is it has a cos 2x. Cos 2x has three options. But we make educated decisions, right? What's on the right-hand side? Cos x. So which one are we going to pick? 2 cos x. 2 cos squared x minus 1. Yeah, try it out. So, cos 2x was 2 cos squared x minus 1 equals cos x. What do I have to do next always when I have a squared? Move everything to? One side set equal to? 0. We learned that at grade 11, right? What? 2 cos squared x minus cos x minus 1 equals 0. Okay, so we can either factor it with the coses in, or you can replace, correct? Yeah. So we're going to get let n equal cos x. 2m squared minus m minus 1 equals 0. What multiplies to be negative 2 and has to give me negative 1? Yeah, negative 2m plus 1m minus 1. Then we group. Take out a 2m. We're left with m minus 1. What do we take out of the second bracket? 1. And we're left with m minus 1. Okay, then we get our two factors, right? 2m plus 1, m minus 1 equals 0. 2m plus 1 equals 0. Now guys, look here. That step has to be shown, right? That step has to be shown where it's equal to 0. We agree? If you just go to m equals negative a half, remember I told you they want to see this step where you actually set each of them equal to 0. You will lose marks. Okay? So we have 2m plus 1 equals 0, m minus 1 equals 0. Then you could go to m equals negative a half from here. That's fine. But you have to show the equal to 0 part. Right, Luke? Yeah. All right. So what do we replace m back with?
Cos x.
Cos x. So cos x equals negative a half. Cos x is equal to negative a half where? Quadrant 2 and quadrant 3 at 60-degree reference angles. So this one is 120 and this one is 240. Yeah, I believe it. All right. Can I put those two together as one solution? Can I put 120 and 240 together as one solution, Caden? Can I put 120 and 240 together as one solution? I don't think so, because you can't. So what was the variable that we had? X. So x equals 120 degrees. What do I have to do next? Oh, yeah, so fun to do. Plus 360 degrees. Next one. Okay, Caden, next one. Since you're on such a roll. Oh, but I believe in you. Cos x equals 1. Where does cos x equal 1? Where does cos x equal 1? Yep. And 360 and negative 360 and blah, blah, blah. So how can I write it? Luke, do I need to write to 0? No, why?
Because 360 times
I thought
0.
you were doing like a parent answer. Because. Why can't I go tonight? Because. But then you can.
360, if n is 0, is already 0.
Right. So you always have to put your initial principal angle between 0 and 360 unless it's 0. Yep. So on the diploma, people have done that. So what they'll do is, on the diploma, on a practice question that's released, they have a statement 1 where it's like how many of the following statements are true. And statement 1 could be these two together, right? Like this one, and this one. And then statement 2 was like someone really out to lunch, possibly not listening while the teacher was teaching. I don't know. Shocking. And then statement 3, people don't pick it, but it's actually correct because they don't notice that these can actually go together. 120, 240, and then we have 360 here. They're actually all 120 apart. So we could write it as x equals 0 plus 120 degrees and NEI. Do I need the 0? No. So it would be 120 degrees and NEI. Could be just one pole solution. So then that would be two true statements, right? But people don't notice that one because they always think of them completely separate instead of together, which is exactly what it is. No one ever picks that up. Not in all my years, sorry. Look at you. Genius child. Okay. Flip over. Guys, what's the problem with these ones? There's a cosecant and a sine. Can they go together? No. Okay, cool. Is there a squared that I can replace? Like a sine squared or a cos squared I can replace? No. Is there a 2x, like a sine 2x or a cos 2x I can replace? No, what's the only thing I can replace? Cosecant with what? Yeah. So it would be 3 over sine x, technically. Now we got problems. Why do we have problems? We have restrictions. We have a denominator. And what can't our denominator equal? 0. So we have to state our restrictions. So we go sine x can't equal 0. Correct? True statement? Where does sine x equal 0? 0, 180, 360, da, keep going, right? So I need to state the restrictions that are in this domain, right? Because the domain's between negative 180 and 180. So which fits in here? 0 fits in here. 180 fits in here. What else? Negative 180. And they're included because we have equal signs. Do you see that? There's an equal sign and an equal sign. All right. So I'm going to say x can't equal 0 and then plus or minus 180 degrees. And I'm going to write that at the very end. Sorry, 0 degrees. I'm going to write that at the very end because I'm going to check my solutions, right? Because what if my solutions are one of these restrictions? What would they be? Extraneous. Yeah. All right. How do I solve this out? What could I do next? Yep. Yes. Multiply by sine x, because my goal is to get that sine x to get out of my life. We agree? So the sine x in the denominator, because right now it's making me have fractions, and fractions make people not happy. So I'm going to multiply this one by sine x so that it cancels. So I can just do that to one term and call it a day? No, what do I have to do? Multiply every term. So this one I have to do it by, and this one. So every term has to be multiplied by sine x. What's 2 sine x times sine x? 2 sine squared x equals 7 sine x minus 3. Do we know how to solve that now? It's just your normal trinomial, correct? So when we have a squared, what do we always have to do? Talk to us in grade 11. Equal to 0. Yeah, move everything to one side, set equal to 0. So I'm going to subtract the 7 sine x and add 3. So I'm going to get 2 sine squared x minus 7 sine x plus 3 equals 0. And then I can keep it as signs, or I can change it to variables. It doesn't matter, right? Whatever you like better. I'm going to keep it as a sign for this one just to show. So 2 sine squared x, what multiplies to give me 6 and adds to give me negative 7? Negative 6 and negative 1, yeah. So negative 1 sine x minus 6 sine x plus 3 equals 0. Group plus sign. What can I take out of the first set of brackets? Sine x. So I'm left with 2 sine x minus 1. What can I take out of the second set of brackets? Negative 3. And I'm left with 2 sine x minus 1. And if you're like, I don't like dealing with the sine x's, can you just replace it with an m? Yeah, go for it. You don't have to deal with the sine x's, right? Bring the sine x back after you factored it. So we're going to get sine x minus 3 equals 0. 2 sine x minus 1 equals 0. Sine x equals 3. And then sine x equals a half. Where does the sine x graph equal 3? Do you remember what the sine x graph? Where does it max out at? 1. Where does it min out at? Negative 1. So I have a graph that's going like this. Right? Max out at 1, min, negative 1. Max out at 1, min, negative 1. Max out at 1, min, negative 1. So here's my positive 1 where it's maxing. And then I have a horizontal line at 3. Where's it crossing? Nowhere. So remember, with sines and coses only, if it's above 1 or below -1, we get what? No solution. Not extraneous. Extraneous means I got a solution, she don't work. No solution means I can't get one. Couldn't find one, looked for a long time, there wasn't. Okay? Then we have sine x equals a half. Where does that happen? $30. Because sine x is the x or the y? The y. And 150. Then I go back here and I look, because you guys, a lot of the time you will just use x's, right? But the variable is actually theta or something like that. So go back and check. The variable is x. Okay, cool. So my answer is x equals 30 degrees and 150 degrees. And then I always follow behind with x can't equal whatever it was, plus or minus 180 degrees and 0. So were any of these those solutions? Were any of the restrictions the actual solutions? No. So do we have any extraneous solutions? No. What do you think I'm going to make you do with B? Yeah, same thing. Swap the secant to a 1 over cos and put the restrictions for cos. So we have 3 cos x plus 2 equals 5 over cos x. Then because I have a denominator, guys, on the test, the worst thing done is non-permissible values. Also, the chapter 5 and 6 trig test is the worst test done of the entire year. So prove me wrong. Yeah. Chapter 6 and chapter 5. Because people think they're like, oh, I got this, and then they don't study it, and then they don't got this. That's how it works. It's like, I don't got this, but, you know, and then they write really nice notes about your teacher being awesome and stuff on it, and hope for marks. I don't know.
Will we get them?
It didn't work. So it was worth a shot. It didn't pan out. Okay. It's not English, but if you make a math poem, maybe. Okay. This would be very interesting. I would like it to follow. I can't even think of any type of poetry. What is it? Iambic pentameter. Next. I don't know what one is. I just remember it. All right. So x, yeah, is the question. This is the answer. Okay, cos x. Boom, boom. So I go 90 and negative 90 multiplied by cos x. And I get 3 cos squared x. If you have this right, and you believe you do, instead of talking, you should try and type this into y1, y2. So while you're watching, you can also be typing that in y1, y2 into your calculators, right? Let m equal cos x. 3m squared plus 2m minus 5 equals 0. 3m squared, but multiply is going to be negative 15, and now it's going to be 2. Positive 5m minus 3m. Oh, I don't know why I went that route. They were not nice together. Take out an m, 3m plus 5. Take out a negative 1, 3m plus 5. Put the blue box back. That's awesome. M minus 1 equals 0. 3m plus 5 equals 0. Okay. M equals 1. Cos x equals 1. And m equals negative 5/3. What's the catch with negative 5/3? Is negative 5/3 lower, smaller than negative 1? Yeah, so what's going to happen? What kind of solution are you going to get? No solution. Remember, it can't be below negative 1 and it can't be above 1. Which does that only work with though? Two trig ratios. Which does that only work with? Sine and cos. Cosecant, cotan, and tan, it doesn't work with. And where does cos x equal 1? 0. The only one, because it's from negative 180 to 180. So x equals 0, and then x can't equal plus or minus 90. Do you guys type it into your calculators? If you're like, how do I type in secant? Remember my comment? If you don't know how to type in something, what do you go to? Starts with an F. Your formula sheet. On your formula sheet it says secant is 1 over cos, correct? So you could just type it as 5 over cos x. This would be y1, this would be y2. What mode do we need to be in? What mode? Degrees. And what do we need to make our window be? Our x minimum? Negative 180, and our x maximum? 180, and then it crosses in one spot, which is 0. So it confirms your answer. That's the textbook. Yeah. So if you don't have your textbook, which you probably don't, this is the only part that's going to be out of your textbook. The rest are actually just homework questions again. But these ones were actually good ones. And the rest of the textbook, chapter 6, not so great. Did I post the online textbook on? I'll look. If I didn't, I'll post it. It's a link. So you can take out your phones because this will be an educational purpose. Unless I see you doing this, that ain't no textbook.